The last lesson of the year is the tangent function. And this function follows the same properties as sine and cosine. However, the graph does look slightly different, as you can see right here. So just to briefly talk about this description, it says, since tangent of theta is equal to sine of theta over cosine of theta, the tangent function is undefined when cosine of theta is equal to 0. Therefore, the tangent function has a vertical asymptote whenever cosine of theta equals 0. So before I read on, let's actually take a look at the unit circle. If we look at the unit circle and identify everywhere where the cosine value or the x value is 0, that happens here at pi over 2, and it also happens here at 3 pi over 2. And of course, if we make another rotation around the unit circle, it would happen again at 5 pi over 2, and once again at 7 pi over 2, and this would continue to move around the unit circle. So the reason why I just highlighted those was to point out where these vertical asymptotes come from. So if we start at 0 on the unit circle, the first time the cosine value is 0 is at pi over 2. There's your first asymptote. The next time the cosine value is at 0 is at 3 pi over 2. Here's your second vertical asymptote. Of course, we can also move in the negative direction as well, so we could have a vertical asymptote at negative pi over 2 and a vertical asymptote at negative 3 pi over 2. This right here, these values on the unit circle, is where the asymptotes come from, which is how you sketch your tangent function. The graph of tangent of theta has the following characteristics. The first one, the domain is all real numbers except odd multiples of pi over 2. That's because the odd multiples of pi over 2 are where the vertical asymptotes are, as we pointed out here. The second characteristic says that the range is all real numbers. And the third characteristic says that the graph has a period of pi, meaning it takes the length of pi to create one full cycle. Looking at our parent function, we have the same general form. We have a times tangent of b times x or times theta, either way, I usually write theta, minus c, and then plus d, with a as your amplitude, b as your period, c and b as your phase shift, and d as your vertical shift. The only thing that's different from anything that we've been doing with sine or cosine is that the period for tangent is just pi over b. It is not 2 pi over b. That is the only difference. Quick note before we move on, when you're graphing, you divide the period into halves to identify the increments of which the intervals increase or decrease by. So previously we divided the period by 4, but this time we only divide it by 2. Looking at the first example, the amplitude, something that we're not going to have to pay too much attention to for a tangent because we're not going to see a lot of changes. The amplitude is 1, but the period is important. And the period is different than previous graphs. The period now is just pi over 2. I'm sorry, pi over b, which in this case is equal to pi over 2. That means it takes a length of pi over 2 to create one full cycle. We're going to divide the period by 2. So divide this in half to determine your increments. So when we do that, we end up with pi over 2 divided by 2, or pi over 2 multiplied by 1/2, which is equal to pi over 4. So here are the increments of increase and decrease on the coordinate plane. So labeling this on the coordinate plane, I'm going to label my increments increasing by pi over 4 or increasing by 1/4 if you think of it that way. I'm actually going to leave myself some room, so let's start with pi over 4. If we add 1/4 to that, we're at pi over 2. Add 1/4 to that, 3 pi over 4. Add 1/4 to that, you're at pi. Now I'm going to label these same points, but I'm going to move in the negative direction. So negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. Now, if the increments go up by pi over 4, then we need to indicate that there are horizontal asymptotes every half unit to basically explain that, or to explain it in a basic way. So our first vertical asymptote is going to be at pi over 4. But then because the period is pi over 2, we need to make sure we leave half a unit until our next asymptote, which is right here. And then, of course, if we were to label another asymptote, it would be located here, which would technically be at 5 pi over 4. Now, if you're confused as to why I labeled those that way, I'm going to explain it another way. So the period is at pi over 2. You can think of that as plotting a point at pi over 2, and it takes the length of pi over 2 to create this cycle. So between pi over 4 and 3 pi over 4, the distance between these points is pi over 2. So not only did we start by plotting our first intercept at pi over 2, because of the period, but I also indicated that my asymptotes would be equally spaced out beyond that in the length of pi over 2. So then we need to repeat this curve. Therefore, the next point, or the next intercept, would be pi over 2 units to the right. There's your next intercept, and it forms between these two asymptotes. So I can repeat this process in the negative direction, knowing that I have a vertical asymptote at -4. So here we are with our x-intercept at 0, and our function goes between those two values. The next vertical asymptote is at -3 pi over 4, with our next intercept at negative pi over 2, and there's your function. So this is the first one we're graphing for tangent. Tangent looks different. It has a bunch of curves. They kind of look like cubic functions. They are not, but that's the form they follow. You just end up regraphing that over and over within each cycle. So each cycle falls between, in this case, a distance of pi over 2. That's one cycle. Here's the next cycle. And of course, it would go on forever. All right, moving on to the on your own section. I already did this one out, and we're just going to take a moment and explain it. So the period here is 2 pi. I know that because I fill in the equation of pi over b, which is pi over 1/2. Multiply that out, you get 2 pi. Then you have to divide the period by 2. Dividing the period by 2 gives you increments of pi, meaning your graph is going to increase by increments of pi. We have pi, next we would have 2 pi, then 3 pi, then 4 pi, then 5 pi, and so on. So you can know to either start graphing your asymptote at pi because of this value here, so we can either match those, or you can plot your first intercept at 2 pi because of this value. And you know that the distance between your vertical asymptotes is going to be a distance of 2 pi. So however you look at that, either way works. Either way is going to give you the final answer. But this is your graph of the tangent function, which is tangent of theta divided by 2. For the next example, we're graphing the same function that we just graphed in the on your own section, but here we have negative tangent of theta over 2. So this is a reflection, but the reflection of the tangent function means you reverse the direction of the curve. to put it in basic terms. So same thing as the problem I explained above. When we find the period of the function, the period is pi over b. In this case, it's pi over 1/2. That is equal to pi pi over 1 multiplied by 2 over 1, which is equal to 2 pi. So I know my first x-intercept is going to be at 2 pi, but I also know it's going to take the length on the coordinate plane of 2 pi in order to create one full cycle. So if I divide 2 pi by 2, I end up with pi as my increments, meaning my graph is going to increase by units of pi. I have pi, 2 pi, 3 pi, 4 pi. In the negative direction, I have negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Now, this number here tells you your first intercept, which is at 2 pi. And this number here tells you your first asymptote, which in this case is at pi. Also, this number tells us that it takes the length of 2 pi to create one full cycle. So pi plus 2 pi is equal to 3 pi, which is where your next asymptote is. And if we were to graph another asymptote, it would be here. I'm going to repeat my steps in the negative direction. These are my asymptotes. Now I know that my first intercept is at 2 pi. I already discussed that one. And I also mentioned that this negative sign up here tells us we're reversing the direction. So now our curves just look as if they were reflected across themselves. So reflected across the center point or the intercept. Imagine the intercept was an axis and it was reflected across that point. And that's the final graph of negative tangent of theta divided by 2. I'll actually add a little bit to this. I didn't mention it, I probably should have, but when you have theta over 2, that's the same thing as 1/2 times theta. That's why it ends up being theta over 2. That's how I know my b value is 1/2. So just as an extra note. Okay, and the last one is the only one we're doing with a phase shift. And phase shifts with tangent functions just get really sloppy because there's a lot going on. There's a lot of lines, there's vertical asymptotes, there's x-intercepts, there's the actual graph. There's just so much going on. So to graph the original function and then shift it, it just looks messy. But that's what we're going to do, so I'll explain this and hopefully everyone follows along. For this function here, we have the period at pi over b, or pi over 1, so it's just pi. That means your first intercept is going to be at pi. It also means a cycle is going to take between 0 and pi. In order to find the increments that I need to increase or decrease by, I divide that number by 2, telling me that I'm increasing and decreasing on my graph by pi over 2. I have pi over 2, plus pi over 2 is pi. Plus pi over 2 again is 3 pi over 2. Plus pi over 2 would be 2 pi. And then 5 pi over 2. And then 3 pi. If I label this in the negative direction, it goes as so. Moving on with graphing, I'm going to plot my first point at pi. So my first intercept is located here at pi. And I'm going to graph my first vertical asymptote at pi over 2. Based on this number, my period, I also know that the cycle takes the length of pi, or the period of pi. Therefore, my next vertical asymptote will be here. I'm going to graph one curve of the tangent function. And before I move on, I'm actually going to pause right there and indicate what my phase shift will be. The reason why I'm going to do that is because the tangent function repeats itself over and over. You're just going to keep having curves across the whole graph. So instead of having all of these lines and having to shift every single one of them, I'm going to find the phase shift and just shift this one single curve, and then I'll repeat the process, or I'll repeat the graph, meaning the curve of the graph. So right here indicates our phase shift. Because we have a subtraction sign, this tells us to shift to the right. Recall that the phase shift is c over b. Our c value is 3 pi over 2. Our b value is 1. So our phase shift tells us to shift this graph to the right 3 pi over 2 units. That means every time you have an x-intercept, or wherever your tangent function crosses the x-axis, just add 3 pi over 2 to that number. The first value that we have is at pi. So if we add 3 pi over 2 to pi, we end up with, of course, a common denominator fraction of 2 pi over 2 plus 3 pi over 2, which is equal to 5 pi over 2. So this point is going to slide all the way over to 5 pi over 2. Not only does the point in the graph slide over to 5 pi over 2, but the whole interval does, or the whole cycle does. That means I am going to shift my asymptotes as well as the function over to 5 pi over 2. And I'm just going to take my graph and do that. So here you can see that our new interval goes between 2 pi and 3 pi, and the tangent function intercepts the x-axis at 5 pi over 2. To continue repeating our tangent graph, my next vertical asymptote would be at pi. My x-intercept would be at 3 pi over 2 with the tangent curve. Next asymptote would be at 0, and then at negative pi, and then at negative 2 pi. And if I just continue for the size of this graph, last one at negative 3 pi, with an x-intercept directly in between all of my asymptotes, and the tangent function repeating itself over and over. If we were to graph this full parent function and then try to shift the whole thing, our graph would certainly look messy, especially because I'm requiring all of you to make sure you're indicating your point values or your increments. So graphing one cycle, including your asymptotes, and then shifting just that one cycle might be your best bet as far as keeping your graph nice and clean for tangent functions. Another thing you could do is make all your marks, make as many transformations or curves as you need to, and then regraph your final answer if you're uploading it into GoFormative. But either way, just be careful because these graphs get messy. For the last on your own section, I'm just going to leave that up to you to look at my note sheet on my website. They are completed, so you can check those out. And if you have any questions, please shoot me an email. Have a nice day, everyone.